Hi everyone, I am Erica Santos and I am here in front of you to show on how to draw the Lewis structure of ions. So before we start, let us all discuss what Lewis structure is. Lewis structure, also known as the Lewis dot formulas, are diagrams that show the bonding between atoms of a molecule as well as the lone pairs of electrons that may exist in the molecule. Electrons are located farther outside an atom. When atoms combine to form compounds, the first subatomic particles in the atom to interact are the electrons. The result of these electrons interactions is called chemical bonds. These chemical bonds are called ionic and covalent bonds. Ionic bonds result from the transfer of electrons from one species to another. On the other hand, covalent bonds result from a sharing of electrons by two or more atoms. This idea was the basis for the formation of the Lewis structure proposed by Gilbert Newton Lewis. Lewis structure is represented by a dot. Take note that the valence electrons are located in the outermost energy level, and these are the ones that will interact first during a chemical reaction. As discussed, elements tend to give up or accept electron to be stable or to be in Hubble gas configuration statement is commonly known as.
In this video, we'll learn to draw the Lewis dot structure for ionic compounds. Ionic compounds are made up of metal and a non-metal, or a metal or a group of non-metals. So I use this color-coded periodic table to identify which of these three are ionic compounds. And be careful because the hydrogen is a non-metal even though it's being grouped on a metal side of the periodic table. For CaCl2, calcium is a metal, chlorine is a non-metal, so this is an ionic compound. For NaNO3, Na sodium, that is a metal, and we have N and O, nitrogen and oxygen, which are both non-metals. A metal and a group of non-metal, that's ionic. And finally, H2O water. H is a non-metal, oxygen is a non-metal, so that is an ionic compound. That's a covalent compound. Is it important to know that in ionic compounds, the metal will transfer those valence electrons to the non-metal, and this influence is how we write the Lewis structure for ionic compounds. So, let's try some Lewis structure. So let's start with the iconic ionic, the NaCl. To write the Lewis structure for sodium chloride, we first look at the periodic table. We see sodium is a metal, chlorine is a non-metal, so we have an ionic compound. Let's write Na and Cl. Next, we need to figure out how many valence electrons each of these elements have. So we go to the periodic table and we can see that sodium is in group 1 and sodium has 1 valence electron. So let's put it in here. Chlorine, that is from group 17, sometimes called 7A, it has 7 valence electrons. We say that in an ionic compound, the metal will transfer its valence electrons to a non-metal. So we have 1 valence electron here, and we have to transfer it to another element, the non-metal chlorine. And when we do that, chlorine has now 8 valence electrons. It is 4 out of shell called an octet, which is very stable. The sodium doesn't seem to have a valence electron, but the shell underneath is full, so it too has a full out of shell because the sodium lost a valence electron and electron is negative, it becomes positive. So we put a plus out here, stand for 1 plus. The chlorine, it gained that electrons are negative. That chlorine is now negative. By convention, we should put brackets around the negative ion. You'll also sometimes see the brackets around the positive ions as well. And that makes it the Lewis structure for NaCl, sodium chloride. Understand that what we drew the Lewis structure for NaCl is actually what's called a formal unit. When you have a crystal that makes up a bunch of these formal units in regularly repeating pattern. So you can see the crystal here, which is the repeating pattern of NaCl, but by writing the Lewis structure formal unit, that helps us understand the behavior of those valence electrons. Okay, here's one more example, a CaCl2 called the calcium chloride. Now, write calcium and we have 2 chlorines, so I put it in here in both sides. We know that the calcium has 2 valence electrons because it's in group 2 in the periodic table. And chlorine, just like before, it's group 17 or 7A, it has 7 valence electrons. The metal will transport electrons to non-metals. So one will go here to give an octet, and then one goes here, and now since the calcium lost 2 valence electrons, it has 2 plus charge. The chlorine, which gains 1 electrons, it become a 1 negative. Then we put brackets around the chlorines, and that makes a Lewis structure for CaCl2, calcium chloride. Let's do one more, NaNO3 sodium nitrate. We have sodium, that's a metal, nitrogen and oxygen, those are both nonmetals, this is an ionic compound. Let's write the Na, then NO3. It's called a nitrate, and when you see this ATE in the end, that's a polyatomic ion, so it's gonna stick together. Nitrogens and oxygens are tightly bound together, so we write NO3. And sodium, because it's in group 1, it has 1 valence electron. But then we have this NO3 polyatomic ion, and that's a little bit challenging because the N and the O, those are nonmetals and it's tightly bound together. We need its Lewis structure just for NO3. We need to draw the Lewis structure for this polyatomic ion NO3, which is usually a covalent compound. So we will replace the NO3 with the Lewis structure, and so we have the Lewis structure for NO3. Sodium, it's a metal, will transfer its valence electron to a nonmetals. Since it lost the electron, it becomes a 1 plus, and the NO3 that gained it become a 1 minus. So we put brackets around the negative ion, and that's make the Lewis structure for NaNO3 sodium nitrate. So let's proceed to the Lewis structure for polyatomic ions. These ions has many atoms, so more than one type of atom in the polyatomic ion, and it has a charge, maybe a 1 minus or a 1 plus or 2 minus. That's how we identify these ions. There's a table that lists the common polyatomic ions. Some structures, they let that use that. The table may look something like this. And you can see we have the different 1 minus, 2 minus, and 3 minus ions, and not very many positive polyatomic ions. We may use this table, then check with this. I do recommend you to memorize the most common one that make chemistry life easier. So back to the Lewis structure for these polyatomic ions. We'll go to this video and do 3 common polyatomic ions. It will be a little bit harder as we go to this video. Let's start with the OH minus. The first thing we need to do for OH minus, it is the hydroxide ion. Count the number of electrons. So while doing this Lewis structure for polyatomic ions, we first count the number of electrons in the periodic table. It can help us look the number of electrons. So we're looking for oxygen, which is right here. So it's in group 6A, sometimes called 16. It has 6 valence electrons. We'll add to the hydrogen. Hydrogen right here is in group 1 called 1AN. It has just 1 valence electrons. We also take and count this charge here when we have this negative that's showing there's an extra electron. Electrons are negative, so we just have a negative sign here to show that there is 1 more valence electron, so we add 1 as well. And then 6, 7, 8, so we have 8 total valence electron to this OH minus Lewis structure. We normally put the least electronegative element to the center, but we only have 2 elements, so they were gonna go next to each other. The oxygen and the hydrogen, we have a total of 8 valence electrons for this OH minus here. So we start by putting a pair of electrons between these 2 atoms that will form a chemical bond. Hydrogen can only need 2 valence electrons, so we're done with hydrogen. For the oxygen, we'll put the rest around the oxygen. We have 2, 4, 6, and then 8. And now, oxygen, it has 8 valence electron, and the octet, it's sharing the hydrogen. So, the hydrogen, it has full outer shell, and this is the Lewis structure for OH minus. We should put brackets around because we want to show that it's an ion. So I'll put brackets here and then in the other side, and then we need to write the charge in this. So we have a minus charge up here, so let's write the minus charge here, and that's the Lewis structure for OH minus. Let's try a positive ion. So it's the same process here. We'll take and count the valence electron for this element, then we use the periodic table, and let's see. We have nitrogen, which is right here, and that's in group 15 or 5AN that has 5 valence electrons. And remember that hydrogen has 1 valence electrons because it's in group 1. We have 1 times 4 hydrogen, and before the negative sign we added 1 valence electron here. We're gonna subtract 1. This positive means it's lost an electron. So 5 plus 4, it's 9 minus 1, so again we have 8 valence electron for this NH4 plus polyatomic ion. Now let's write the Lewis structure. The least electron is in the center, then hydrogen is in the outside. We just put N here in the center, and then 4 hydrogens atom around it. We have 8 valence electrons. We'll put valence electrons between atoms to produce chemical bonds, and in this case, we use all 8 of them. Hydrogen has 8 valence electrons, and each hydrogen has 2, so this is the Lewis structure for NH4+. Just put our bracket around it again, and then since it's positive ion, we'll write the positive sign after. So that's the Lewis structure for polyatomic ion NH4+. Let's do one that's a little bit different. Cn-. This is a cyanide ion. It is a negative charge here, so this is a polyatomic ion. So let's write the Lewis structure again. It's only 2 things, we just put C and N, and then let's count its valence electron. Carbon right here is in group 4A, sometimes called 14. It has 4 valence electrons plus the nitrogen, which has 5, and then we have a negative charge, so let's add 1 here. That's 9 plus 1, so 10 total valence electrons for that polyatomic ion here, the Cn-. Let's write the structure. We'll start by putting a pair of electrons between the atoms that forms the chemical bond, and then we go around and then we completely octet on each of the atoms, but we only have 10 valence electrons, so we use 2, 4, 6, 8, and 10, and you can see carbons are fine with an octet and nitrogen does not have an octet. So with this type of structure, what we can do is we can move some electrons around. So let's move this right here to form a double bond. Why don't we move this one more here between here to form a triple bond? So now we have 8 around the carbon and 8 around the nitrogen. So this is the Lewis structure for polyatomic ion Cn-. Let's just move it here for symmetry. Then we need to put our brackets around, and since it's a negative ion, we put the negative charge out here. That's the Lewis structure for Cn-. And that's the simple ways on how to draw the Lewis structure of ions. Hope you find it easy. Bye!
Lewis structure, also known as the Lewis dot formulas, are diagrams that show the bonding between atoms of molecules as well as the lone pairs of electrons that may exist in the molecule. Electrons are located farther outside an atom. When atoms combine to form compounds, the first subatomic particles in the atom to interact are the electrons. The result of these electrons interactions is called chemical bonds. These chemical bonds are called ionic and covalent bonds. Ionic bond result from the transfer of electrons from one species to another. On the other hand, covalent bond result from a sharing of electrons by 2 or more atoms. This idea was the basis for the formation of the Lewis structure proposed by Gilbert Newton Lewis. Lewis structure is represented by a dot. Take note that the valence electrons are located in the outermost energy level, and these are the ones that will interact first during a chemical reaction. As discussed, elements tend to give off an accept electron to be stable or to be a noble gas configuration. This commonly